All right, welcome back everyone. Let's go through the solution for the Now You Try problem on using GeoGebra to find the key elements of a quadratic function's graph, a parabola. So the problem says to graph the quadratic function g of x equals negative x squared minus 3x plus 4 using GeoGebra, and then identify the following elements: the vertex, the axis of symmetry, the y-intercept, the y-intercept's mirror point across the axis of symmetry, and the x-intercepts. We can probably just shrink that down a little bit. That's fine, I believe. All right, so we open up GeoGebra, we click Start Calculator, and then we will go ahead and wait for it to load and plop in the function g of x equals negative x to the second minus 3x. Oops, does that, got to get out of that exponent, minus 3x and then plus 4. And we'll take a look at the graph here. We'll begin by identifying the vertex. Looks like it's up here at negative 1.5 comma 6.25, that top point on the parabola. And I'll write that down, that it is negative 1.5 comma 6.25. And I'll go ahead and put it in GeoGebra as well. So vertex equals negative 1.5 comma 6.25. And make it so that that shows the value as well. Next, we want the axis of symmetry, and that's the vertical line that goes through the vertex. So I'm going to type in x equals negative 1.5, and I'll go ahead and just make that look a little bit nicer here, make it a dotted line, change its color, and let's call it equation 1. Let's show the value there, x equals negative 1.5. I'll go ahead and write that into my work on the left. I have the axis of symmetry as the equation, x equals negative 1.5. And then we want the y-intercept. So over here on the graph, I can click on where the parabola crosses the y-intercept and see that it is the point 0, 4. For this problem, the mirror of this is pretty easy to find. It's at a nice whole number here. So let's real quick put the y-intercept. So y equals 0, 4. And get the label on that as well. And then we want the y-intercept's mirror point, and so that's going to be at negative 3, 4. We can use that solving process again by setting the function g of x equal to 4, and it should give us 3 as the output. There we go. So we've got that labeled, and then we need the x-intercepts. So we've got negative 4, 0. Call that x1. And then x2 looks like it's at 1, 0. Plop that in. We'll get these values shown. And then we'll go ahead and write this all into our worksheet here. Got the y-intercept's mirror point is negative 3, 4, and the x-intercepts are negative 4, 0, and 1, 0. And we'll take a screenshot. So that I can then pop this down into the worksheet. Whoa, that's not where I want to put it. I want to put it over here. Come on. I hate fighting software. It's annoying. There we go. All right, that's it. That's all we're looking for in this. I hope that this has been helpful in remembering what these points are by their names, and that you can use GeoGebra to find this information whenever you need for these. Thanks so much for watching, and we'll see you soon.